Hey everyone, and welcome. Today, we are going to tackle a real classic in the coding world, finding the longest substring without any repeating characters. Now, it might sound simple, but the solution, it's incredibly clever. So let's dive right in. So right off the bat, here's the puzzle. Take a look at this string, pwwkew. What's the longest piece of that string you can find that doesn't use the same letter twice? Just, take a second. You might see WK or maybe KW. Both are 3 letters long. But is that the best we can do? And, more importantly, how do we get a computer to figure this out perfectly every single time? Okay, so your first instinct, like mine, would probably be to just start checking every single possibility. You check P, then PW, then PWW, then you'd start over at WWWK. You see where this is going, right? Imagine if this string was 1,000 characters long. That brute force approach would just grind to a halt. We'd be checking millions of combinations. Yeah, that's just not going to work. And this is where you can really see the problem. We check P, all good. PW, still good. But bam, we hit PWW and there's a repeat. So what do? We have to throw out everything we just did and start all over again from the next character W. Then we immediately hit WW and have to start over again. It's just so much repetitive, wasted work. But don't worry, because there is a much more elegant solution to this. It's one that avoids all of that tedious rechecking and gets us to the answer with, honestly, remarkable efficiency. And that solution is called the sliding window technique. The main idea here is actually pretty simple, but it's so powerful. Instead of checking every single substring from scratch, we create this dynamic window over our string. So when we run into a problem, instead of throwing everything out, we just intelligently slide and resize the window. It's a total game changer. Let's just put these two ideas side by side. Brute force is just clumsy, right? It checks tons of overlapping, redundant parts of the string over and over. The sliding window, on the other hand, is surgical. It expands when everything's fine, and it smartly contracts the moment it finds a repeat. Basically, each character only gets visited once. That's what makes it so incredibly fast. So to actually build this sliding window, we only need a few simple tools. We're going to have a left pointer to mark the start of our window and a right pointer for the end. The real magic, though, is the HashMap. Think of it like our program's memory. It's a way for us to instantly ask, hey, have I seen this letter before and where was it? That instant recall is what makes the whole thing zoom. And of course, we need a variable to keep track of our best score so far. All right, enough talk, let's really get into it. We're going to trace the code step by step using our original example string pwkew. We're going to watch exactly how our pointers, our window, and our character memory all work together to solve this thing. Okay, so we start with both pointers right at the beginning, at index 0. The right pointer looks at the first character, P. It's new to us, so our window is just P. Our max length is now 1, and we store in our map, our memory, that we saw P at index 0. Simple enough, right? Now the right pointer slides over 1 spot to W. So far so good, no repeats. Our window expands to PW, and we've hit a new max length of 2. We just log that W and its position into our memory map, and we keep going. All right, here we go. This is the fun part. The right pointer moves to index 2. And what does it find? Another W. Uh-oh, it's a repeat. Now this is exactly where that brute force method would have given up and started all over. But our sliding window, it's way smarter than that. The absolute key to this whole thing is this single line of code. When we find a repeat, we just look up the last place we saw that character. Our map tells us instantly, and then we jump our window's start right past it. We don't just inch forward one by one. We make an intelligent leap. This is the secret sauce. And here's that jump in action. Our map tells us the old W was at index 1, so our left pointer leaps forward to index 2. Now notice what just happened. We didn't just throw away the P. We instantly created a brand new valid window, just W, all in a single step. We avoided all that wasted rechecking. Okay, conflict resolved. The right pointer just keeps on moving, and now it lands on K. K is new, so our window expands to WK. The current length is 2, which doesn't beat our record of 2, so our max length just stays put. We just update the map with K's new position. Next, the right pointer moves to E. Again, it's a new character, so the window grows to WKE. Now, what's the length of that? It's 3. And that is a new record, so we update our max length to 3. And of course, we record where we saw E in our map. And for our very last character, what do you know? It's another W. We've seen this before. Our map tells us the last W we dealt with was at index 2. So what's the rule? The left pointer jumps one spot past it, all the way to index 3. Our final window becomes Q. Its length is 3, so our max length stays at 3, and we just update our map with the newest location for W.
And just like that, our right pointer has hit the end of the string. The loop is over. We've processed the entire thing in one single efficient pass. No starting over, no wasted effort.
So what's the final answer that we return? It's that value we were so carefully tracking the whole time in our max length variable. The longest substring without any repeating characters is indeed 3. So, cool, we solved the puzzle. But why does this specific technique actually matter? Well, because it's not just a one-off trick for this one problem. It's a fundamental pattern for solving so many others. So let's just boil it all down. The number one takeaway is the sliding window pattern itself. Anytime you need to analyze a continuous chunk of a sequence, your brain should go, maybe a window could work here. The engine that makes it so fast is that HashMap, giving you that instant memory. Mastering this isn't just about passing a technical interview. It's about making a mental shift from brute force thinking to writing truly elegant and efficient code. And that brings us to the end. So I'll leave you with this question to chew on. Now that you get this pattern, what other kinds of problems could you solve by just thinking in terms of a window that slides over your data? Thanks so much for watching.